Hi guys, so now we're just going to do the your turn example from lesson 5.5. This is also a Pythagorean theorem question. So our first question says an airplane is flying due east at a constant altitude of 16 kilometers and passes directly over an air control tower. So I'm just going to start off by drawing this. My height is 16 and it says that it's constant, so I know that I'm going to have a nice right triangle. This is my tower. And up here is my plane, which is moving due east. Later, the plane passes over a route marker which lies 12 kilometers east of the tower. So I know that my distance here is 12 kilometers. At this moment, the distance between the tower and the plane is measured to be at a rate of 400 kilometers per hour. So a rate of 400 kilometers per hour. This is going to be my diagonal distance or my hypotenuse. So we can see I've created that right triangle. So now I'm going to start off by labeling everything. My vertical line is going to be my y. My horizontal line is going to be x, and I'm going to call my hypotenuse my z value. So let's see what we know about all of them. I know that my vertical distance is 16, and that's a constant, so I don't need to worry about dy by dt, it's just 0. I know that I have an instantaneous time of x, which is 12, but this is also changing. So I do have a dx by dt value, and that's actually what we're looking for, what we're solving for. My z value is also changing over time, and my dz by dt value is given in the question for 400 kilometers per hour. So let's see what we can do to solve this. I have a right triangle, so the best thing to do is Pythagorean theorem, where y squared plus x squared would equal z squared. If I took the derivative of this, my derivative of y squared, it's a constant, it's going to be 0, I don't have to worry about it. My derivative of x squared is 2x dx by dt. My derivative of z squared is 2z dz by dt. So right now if I go look at it, I have a value for this, I have a value for this x, but I don't know dx by dt and I don't know z. So I need to take a break and I need to solve for one of these unknowns because otherwise I can't solve my problem. Since I have a right triangle, I have enough information to actually solve Pythagorean theorem for this instantaneous time of 12 kilometers. So this is 16, this is 12, and I have a z on my diagonal line. If I solved this Pythagorean theorem, you would get z is equal to 20. So you guys can do that on your own just to make sure that's right. So now filling all that information back in, I have 2 times 12, that was given in our question, dx by dt, this is our unknown and what we're solving for, equals 2 times 20, dz by dt, which is 400, that was also given in our question. So moving everything over to the other side, I have dx by dt equals 2 times 20 times 400 over 2 times 12. So these 2's will cancel out. This here can simplify to 5 over 3. So I get 666.6 kilometers per hour as my solution. And this is positive because all of my distances are increasing.